Hello children, welcome to the YouTube live class of Standard 8. Today we are going to learn Unit 12 Atomic Structure, the remaining topics. So in the last class we have discussed the discovery of the fundamental particles like proton and electron and the discovery of neutron. The discovery of neutron you will learn in your higher classes briefly. Okay, so today we are going to continue with Thomson's atom model. Okay, so we are going to continue with Thomson's model. Thomson's atom model. Okay, so J.J. Thomson, an English scientist, proposed the famous atom model in the year 1904, and just after discovery of electron. Okay, so now, what is the proposal of Thomson? So he proposed that the atoms are solid sphere. Okay, he told that atoms are the solid sphere. He compared atom to the solid sphere, and the whole solid sphere is considered as positive charge. Okay, in that the electrons are distributed uniformly. Okay, so here the atom, he compared an atom to a solid sphere. What he compared? He compared the atom with the solid sphere. Atoms are solid sphere with a diameter 10 to the power of minus 10 meter. Okay, so with the diameter 10 to the power of minus 10 meter. Okay, he told that all the atom is made up of positive charge. That means it's made up of protons. And the electrons are distributed, evenly distributed, uniformly distributed within the negative charge, within the positive charge. Okay? Yes. So the positively charged particles are uniformly distributed with electrons arranged in such a manner that the atom is electrically neutral. And further he told that atoms are electrically neutral. He added further that atoms are electrically neutral. So what does mean by electrically neutral? That means in an atom, the number of protons is equals to the number of electrons. Okay, the number of protons is equals to number of electrons. Number of protons is equals to number of electrons. Okay, so in an atom, the number of positive charges and the negative charges are equal. So that's what we are calling atoms are electrically neutral. So he added that atoms are electrically neutral. Electrically neutral means number of protons is equals to number of electrons. So in an atom, the number of protons and electrons are equal in number. Okay. Yes, Thomson's atom model was also called as plum pudding model or the watermelon model. The embedded electrons resemble the seed of watermelon, while the watermelon's red mass represented the positive charge distribution. The plum pudding atomic theory assumed that the mass of an atom is uniformly distributed all over the atom. Okay, so he compared. So the Thomson's atom model is compared to the watermelon or the plum pudding model. Okay, we can compare the Thomson's atom model to a watermelon or the plum pudding. Okay, so in that, for example, in a watermelon, the red mass is considered as the positive charge, and the seeds embedded in it are considered as electrons. Okay, the red mass of this watermelon are considered as the positive charge, and the embedded seeds are considered as electrons. Okay, this is electron and this one is a proton. Okay, so we can compare the Thomson's atom model to a watermelon. So in the watermelon, the red mass is considered as the positive charges. In the positive charges, the electrons are embedded like seeds in the watermelon. Okay, so The seeds in the watermelon as considered as electron. Okay, so the electrons are embedded in the positive charges. Okay, yes. So, limitations of Thomson's atom model. So, what are the limitations of Thomson's atom model? Thomson's atom model could successfully explain the electrical neutrality of atom. Okay, Thomson can able to explain how the atoms are electrically neutral, but he failed to prove that Thomson's model failed to explain how the positively charged sphere is shielded from the negatively charged electrons without getting neutralized. This theory explains only about the protons and electrons and failed to explain the presence of neutral particle neutron. So in this experiment, in this model, in his atom model, he explained only about the protons and electrons and what is the neutron. And there is no evidence of neutron in his model. Okay, so no neutron. So he didn't explain about the neutral particle neutron in his atom model. Okay, and one more failure is that he couldn't explain how the positive, like actually he told that the positive charges, the electrons are embedded in the positive charge. So how the positive charges are shielded themselves from the electrons, because protons and electrons are attracted each other. Is it? They are opposite charges, so they attract each other. So he couldn't explain how the positive and the electron charges are shielded with each other. Okay, how the protons are shielded from the electrons without attracting. Okay, so this is the failure of Thomson's atom model. Okay, yes. So Thomson's model failed to explain how the positively charged sphere is shielded from the negatively charged electron. This positively charged sphere, how it is shielded from the negatively charged electrons. Okay, because the positive and electrons are attracted with each other. Okay, he couldn't explain how the positive charge shielded themselves from the electrons. Okay, yes. Next, this theory explains only about the protons and electron and failed to talk about the neutral particle neutron. Okay, so these are the failures of Thomson's atom model. Next, we will continue with the valency. Valency. So in order to understand valency of elements clearly, we need to learn a little about Rutherford's atomic model here. According to Rutherford's model, to understand about the valency, we need to know the Rutherford's atomic model. Rutherford's According to Rutherford, an atom consists of subatomic particles, namely proton, electron and neutron. Protons and neutrons are found in the center of an atom called nucleus. Electrons are revolving around the nucleus in a circular path called orbits or shells. An atom has a number of orbits and each orbit has electrons. The electrons revolving in the outermost orbit are called valence electrons. So we need to know, before we need to know about the valency, we need to know about the Rutherford atomic model. Okay, in Rutherford atomic model, According to Rutherford, the three subatomic particles are, he explained how the three subatomic particles are arranged in an atom. Okay, so he told that in an atom, the protons and neutrons are in the center of the nucleus. Okay, at the center of the atom. Okay, the protons and neutrons at the center of the nucleus, in center of the atom in the nucleus. Okay, so the nucleus is at the center of the atom. In the nucleus there is the presence of proton and neutron. And where are the electrons? The electrons are revolving around the nucleus. The electrons are revolving around the nucleus in an, the electrons and neutrons, the electrons are revolving around the nucleus in a circular path. Okay, where they are revolving? They are revolving around the nucleus in a circular path. This circular path is called as orbit. Okay, yes. So this is the nucleus. In the nucleus, there is the presence of proton and neutron, and the electrons are revolving in an orbit. So the electrons are revolving in an orbit. Okay? Yes. The electrons are revolving around the nucleus in an orbit. Okay? Yes. So, protons and neutrons are found at the center of an atom called nucleus. Electrons are revolving around the nucleus in a circular path, that is called the orbit. Okay? Orbit or shell. Otherwise it is known as shell. Okay. And the electrons which is in the outermost shell. Okay? So, electrons which is in the outermost shell is called as valence electron. Okay, the electrons in the outermost shells are called as valence electron. Okay, so these electrons are called valence electron. So the electrons which is in the outermost shell are called valence electrons. Okay, yes. So an atom has a number of orbits and each orbit has an electron. The electrons revolving in the outermost orbit are called valence electrons. So the electrons, so around the nucleus in an atom there is a number of orbits. Okay, so there are number of orbits in an atom depending upon their atomic number. Okay, yes. So the electrons are revolving in an orbit and the electrons which is present in the outermost shell is called as valence electron. Okay, and the electrons which is present in the outermost shell or orbit is called as valence electron, because the electrons which is in the outermost shell only going to participate in the chemical reaction. Okay, so that's what it's called as valence electron. Okay. The arrangement of electrons in the orbit is known as electronic configuration. And one more thing, what is electronic configuration? The electronic configuration is nothing but the arrangement of electrons in an atom. Okay, the electronic configuration is nothing but the arrangement of electrons in an orbit is known as electronic configuration. Okay, so actually there are four main orbits in the atom. That is, they are K, L, M and N. Okay, these are the four principal orbits around the nucleus in an atom. K, L, M, N. Okay, so electronic configuration is nothing but the arrangement of electrons in an orbit. Okay, so the electronic configuration in an orbit is given by the formula 2n square. Okay, so if n is equals to, so the orbit which is next to the nucleus is K and the second orbit is L, and the third one is M, and the fourth one is N. Okay, K, L, M, N. If N is equals to 1, that shell is called K. If N is equals to 2, that shell is called L. If N is equals to 3, that shell is called M. And if N is equals to 4, that shell is known as N. Okay, if we substitute the N value in the given formula 2N square, 2 into 1, the whole square. So we'll get 2. So in the K shell, how many electrons can accommodate? We can accommodate, that is the accommodation of 2 electrons in K shell. Okay, so K shell can occupy only, so 2 electrons only can occupy the K shell. Okay, and what about the L shell? If N is equals to 2, 2 into 2 the whole square, so 4, 2 into 4, we will get 8 electrons. So in the L shell, 8 electrons only can accommodate. Okay, then if N is equals to 3, that shell is M. Okay, that means 2 into 3, the whole square. Okay, so what do we get? 9 into 2, so 18 electrons can accommodate in the L shell. Okay, and what about N? N, if we substitute the 4 value in the N's place, so 4 into 16 and 2, so totally 32 electrons can accommodate in the N shell. So these are the electronic configuration. Okay, the arrangement of electrons in an atom is called electronic configuration. Okay, so K shell can accommodate K shell can accommodate 2 electrons. So in K shell, 2 electrons can accommodate. In L shell, 8 electrons, and in M shell, 18 electrons, and in N shell, 32 electrons can accommodate. Okay, yes. But in this, these are the orbits. They are the principal orbits. Okay, in these orbits there are subshells of it. Okay, there are subshells in each the shells. Okay, like S, P, D, and F. Okay, this you will learn in your higher classes. Okay, yes. So electronic configuration is nothing but the arrangement of electrons in an orbit. Okay, that is called electronic configuration. Yes. So atom of all elements will tend to have a stable electronic configuration. That is, they will tend to have either 2 electrons or 8 electrons. That is known as triplet or octet in their outermost orbit. For example, helium has 2 electrons in the outermost orbit, and so it is electrically inert, chemically inert. Similarly, neon is chemically inert because it has 8 electrons in the outermost shell. Okay? Yes. So one more thing in the valency, that is yes. See all the electrons, all the atoms are tend to get the 8 electron configuration in their outermost shell. Okay, yes. See, atom of all the elements will tend to have a stable electronic configuration. The stable electronic configurations are 2 and 8. Okay, the 2 stable electronic configurations known as tuplet. That means the atoms try to attain the tuplet state and the octet state. Okay, that means if an atom, the outermost shell of an atom contains 2 electrons, that is considered as a stable atom. Okay, and if an atom contains 8 electrons in their outermost shell, that atoms are called as stable atoms. They are called stable atom. Okay, the atoms which do not possess the 2 and 8 electrons configuration in the outermost shell are called as unstable atoms. Okay, so usually the atoms try to attain the stability. Okay, they try to attain the 8 electron configuration in their outermost shell. Okay, so for example, we will take helium and neon. Okay, helium and neon are inert gases. Okay, yes. So here the atomic number of helium is 2 and the atomic number of neon is 10. Okay, yes. So here helium atom consists, we have 2 protons in their outermost in the nucleus, and they will have 2 electrons in their outermost shell. Okay, yes. And what about neon? Neon has 2 shells around it. Okay, in the nucleus of neon, there is 10 proton. So here it contains 2 proton. Okay, and as you already know, number of proton is equals to number of electrons. So 10 proton in the nucleus and 10 electrons in the outermost shell. As we know already, the K shell can accommodate 2 electrons. Okay, and the remaining 8 is accommodating in the electrons are accommodating in the L shell. Okay, here you notice the number of electrons in the outermost shell. There are 8 electrons. So here you notice in the helium, the number of electrons in the outermost shell is, so there is only one shell in helium, and in neon there are 2 shells. Okay, helium there are only one shell around the helium, around the nucleus. Okay, and in neon there are 2 shells, that is K and L shell. But helium has only one shell. Okay, the K shell can accommodate only 2 electrons. Okay, and what about the L electron? The L shell can accommodate 8 electrons in the outermost shell. So here you notice these 2 atoms are called stable atoms, because they contain the 8 electrons in their outermost shell. Okay, this atom contains 2 electrons in their outermost shell, and here this contains 8 electrons in their outermost shell. Okay, so if the atoms contains the 2 and 8 electrons in their outermost shell, then the atoms are called as stable atom. Okay, so the atoms which do not contain the 8 electrons in their outermost shell are trying to attain the octet. Okay, most of the elements are trying to attain the octet state to make it stable. That's what they are taking part in the chemical reaction. But these 2 atoms have no necessity to take part in the chemical reaction. Why? Because the outermost shell is already filled with the electrons. Okay, so these atoms are called inert. Okay, these elements are called, the atoms from these elements are called inert. Okay, they are inert elements. Okay, they are inert gases. So these 2 are gaseous atoms. Okay, that's what is called as inert gases. Inert. Okay. So next, the valence electron in an atom readily participate in a chemical reaction, and so the chemical properties of an element are determined by these electrons. When molecules are formed, atoms combine together in a fixed proportion because each atom has different combining capacity. This combining capacity of an atom is called valency. Valency is defined as the number of electrons lost, gained or shared by an atom in a chemical combination, so that it becomes chemically inert. Okay, so as we already know, every atom try to attain their stable electronic configuration. That means 8 electronic configuration in their outermost shell. Okay, yes. So to make it stable, the atoms are trying to, by losing its electron or gain an electron, okay, or making ions, they are trying to attain the stable electronic configuration. Okay, so to attain the stable electronic configuration, the atoms are losing their electron or gaining their electron, and they are creating their ions, okay, to make them chemically inert. That means they try to make them stable. Okay, that's what they are, taking part in the chemical reaction and forming molecules. Okay, yes. So each atom has the different valency. So the valence electron in an atom only determines the valence electron. The valence electron in an atom only decides the chemical property of the atom. Okay, so the valence electron only that is responsible to decide the chemical property of the elements. Okay, that will be the types of valency. So next, electron, in order to attain the stable electronic configuration. In order to understand the valence in a better way, it can be explained in two ways depending on whether the atom gains or loses electron. Atoms of all metals will have 2 to 1 to 3 electrons in their outermost orbit. By losing these electrons, they will have stable electronic configuration. So they lose them to the other atoms in the chemical reaction and become positively charged. And such atoms which donate electrons are said to have positive valency. For example, sodium atom has 1 electron in its outermost orbit, and in order to have stability, it loses 1 electron and becomes positively charged. Okay? See, as we already know, so all the atoms are trying to attain their 8 electrons configuration. Is it? Yes. So that's what atoms are losing or gaining an electron to attain the octet state. Okay, to gain the octet electronic configuration. Okay, so for example, so as we already know, the valence electrons in the outermost shell only decides the chemical properties of the elements. Okay, so for example, metals, all the metals have the valence electron. The valence electron of the metals are from 1 to 2, 3. 1, 2, 3. Okay, the metals, the valence electrons of metals are 1, 2, 3. Okay, all the metals. So in all the metals, the outermost shell contains 1 to 3 electrons. Okay, so for example, sodium and aluminum. I will take the 2 examples. The sodium and aluminum are metals. Okay, and what is the atomic number of sodium? It is 11. And the aluminum is 13. Okay, and what about the electronic configurations? You look at here. Sodium have 11 protons in their nucleus and 11 electrons in their outermost shell. 2 electrons in the K shell, 2 electrons in the K shell, and the remaining electrons. Eight electrons, so 10. The remaining one is present in the M shell. Only 1 electron in their outermost shell. Okay, so sodium contains 2, 8, 1. The electronic configuration of sodium is 2, 8, and 1. And what about aluminum? Aluminum 30 proton in the nucleus, and the electrons are 2 electrons in the K shell. Again, 8 electrons in the L shell. The remaining 3 is present in the outermost shell. Okay, so there are 3 electrons in their outermost shell. So what is the electronic configuration of aluminum? It is 2, 8, 3. Okay, so these are the metals. They are containing So sodium is a metal which contains 1 electron in their outermost shell. Okay, and aluminium, it contains 3 electrons in the outermost shell. So these are called metals. Okay, so the valence electron which is present in the outermost shells only deciding their chemical property. Okay, so electrons which contains which contains the valence electron 1, 2, 3 are considered as metals. Okay, yes. So the valence electron decides the chemical properties of an element. Okay, yes. So here, to make it stable, what the sodium is doing? So if the sodium loses 1 electron from its outermost shell, it becomes if sodium loses its 1 electron, the electronic configuration of sodium will become 2, 8. Okay, it becomes 2, 8. Okay, if it loses 1 electron, its outermost shell contains 8 electrons. Okay, so sodium is stabilized. Now the sodium is stabilized by lose 1 electron. Okay, by losing 1 electron. Okay, so this is called actually. So here the number of for sodium now it loses 1 electron. So there are 11 proton. But what about the number of electron? 10 electron. Okay, 11 proton and 10 electron. So here the number of protons is higher. So that's why we are writing sodium as positive ion, Na+. Okay, this is actually sodium. When sodium loses its 1 electron, it becomes Na+. That means the number of proton is higher than that of number of electron. Okay, the number of proton is more, so that's why here Na+. Okay, so what about here? So here in this case, if aluminium loses 3 electron, okay, it will become 2, it will get 2, 8 configuration. Okay, 2, 8 electronic configuration. Okay, so aluminium uses 3 electron to make it stable. Okay, to make it stable, it uses 2 electron and get the configuration of 2, 8. Okay, so aluminium loses 3 electrons. So we will write it as Al3+. That means here the number of proton is 13 and number of electron here is 10. Okay, so 3 more protons are more in this atom. Okay, so this is called positively charged ion or otherwise cation. Okay, yes. So all non-metals will have 3 to 7 electrons in their outermost shell. So far we have discussed the metals. Now, so this is example for the atoms which is losing the electron. Okay, which forms a negatively charged ion. Sorry, positively charged ions. Okay, another example with non-metal. So non-metal will have 3 to 7 electrons in their outermost orbit of their atoms. In order to attain stable electronic configuration, they need few electrons only. So they accept these electrons from the outermost atoms in a chemical reaction and become negatively charged. These atoms which accept electrons are said to have negative valency. For example, chlorine atom, the atomic number of chlorine is 17 and it has 7 electrons in their outermost orbit. See, here we will take chlorine. Chlorine, the atomic number of chlorine is 17. Okay, and what about the electronic configuration of chlorine? Yes, this is 2, 8, and 7. Okay, so totally 17 electron. Okay, Yes. But in the outermost shell, how many electrons are there? 7 electrons in their outermost shell. So, if chlorine gains 1 electron, it will become stable. Okay, if chlorine gains 1 electron, it will become stable. It will attain their octet electronic configuration. Okay, 2, 8, 7. So, chlorine, which has 17 proton, and in the outermost shell, there are 3 outermost shell. Okay, 2 electrons, the first shell, and 8 electrons in the second shell, and 8 electrons in their second shell. And what about this shell? There are 7 electrons. There are 7 electrons in their outermost shell. Okay, yes. To make it stable, what the chlorine is doing? Chlorine accepts 1 electron. It gains 1 electron. Okay, if it gains 1 electron, it will become, if chlorine accepts 1 electron, that is plus electron, it will become 2, 8, 8. Okay, it attains the electronic configuration 2, 8, 8. So it attains a stable electronic configuration. That means it attains the octet state, the octet electronic configuration. Okay, yes. So in this way, so here the number of proton, 17 proton, it contains 17 proton. And what about the electron? The electron, yes, the electron it contains is 18. Okay, the electrons it contains is 18. And what about the proton? It contains 17. So there is 1 excess of electron. So the number of electron here is more. That means 1 electron is excess in this atom. So we will put Cl minus. Okay, it is negatively charged. Okay, yes, it is otherwise known as anion. Okay, if you see the minus charge, we should call it as anion. Yes. So by gaining 1 electron, it attains stable electronic configuration like inert gas electronic configuration. Thus, chlorine has negative valency. Okay, chlorine has negative valency and the sodium has positive valency. Okay, so if the sodium plus chlorine combined with each other, both will attain the stable electronic configuration. See, for example, as we already know, sodium electronic configuration of sodium is 2, 8, 1. What is 11? And what about chlorine? The electronic configuration is 2, 8, and 7. So here the chlorine gives 1 electron to this chlorine. Okay, so here the sodium loses its electron and chlorine gains an electron. Okay, if we combine, so they combine with each other. So here after formation, sodium will attain the 2, 8 and the chlorine will attain the 2, 8, 8 configuration. Okay, so here you notice the outermost shell of the sodium contains 8 electrons and here the chlorine contains 8 electrons. So here the sodium loses its 1 electron, it gives its 1 electron to chlorine to make it stable and the chlorine gains 1 electron. Sodium loses its 1 electron, that means it gives 1 electron to chlorine to make it stable and chlorine gains 1 electron from sodium to make it stable. Okay, so the atoms try to attain their 8 electron configuration in the outermost shell. Then only they are considered as stable atoms. Okay, they try to attain their stable electronic configuration. So that's what they are gaining or losing electrons. Okay, so if If atom gains electron, okay, that atoms are called, yes, as we already know, chlorine. Chlorine gains one electron, so it forms negative charge. Okay, it's negatively charged. If it contains, if an atom gains an electron, that atoms are called negatively charged atom. Okay, negatively charged atom. Or anion. Okay, if the atoms, if atom loses electron, that forms positively charged electrons. That forms positively charged atoms. Positively charged atoms. And that is called cation. So that's what we are forming cations. Okay? Yes. Next, valency with respect to atoms. So far we have learned about the types of valency. Okay? Now we will continue with valency with respect to atoms. So valency of an element is also determined with respect to other atoms. Generally, valency of an atom is determined with respect to hydrogen, oxygen and chlorine. So we can determine the valency of some atoms. Okay, so we can compare the valency of atoms with hydrogen, oxygen and chlorine. Okay, so we can determine the valency of other atoms by comparing with hydrogen, oxygen and chlorine. Okay, yes. So first with valency with respect to hydrogen. So valency with respect to hydrogen. Since hydrogen atom loses one electron in its outermost orbit, its valency is taken as 1. It is selected as the standard. So valencies of other elements are expressed in terms of hydrogen. This valency of an element can also be defined as the number of hydrogen atoms which combine with one atom of it. In hydrogen chloride molecule, one hydrogen atom combines with one chlorine atom. Thus, the valency of chlorine is 1. Similarly, in water molecule, two hydrogen atoms combine with one oxygen atom. So, valency of oxygen is 2. Okay. So, we already know the valency of hydrogen is 1. So, the atomic number of hydrogen is 1. Okay. So, hydrogen contains only one proton in their nucleus and one electron in their outermost shell. One electron in their outermost shell. So, it has only one electron. So, the valency of hydrogen is 1. Okay, so because it contains only one electron in their outermost shell. Okay, so we can decide the other atoms, the valency of other atoms when they combine with hydrogen. See, for example, hydrogen and chlorine. Okay, hydrogen chloride. Okay, the formation of molecule hydrogen chloride. So here we can say that the valency of chlorine is 1. Why? Because hydrogen can combine with only one atom. So the valency of chlorine also 1. Okay, so the valency of chlorine is 1. Because the hydrogen has the valency of hydrogen is 1. Because it has only one electron to share. So the valency, so it can combine with only one atom. So what about the chlorine? The chlorine, if the chlorine combines with hydrogen, we can say that the valency of hydrogen, the valency of chlorine is also 1. Okay? Yes. Next, we will take another example. Water molecule. Okay, H2O. Okay, so here in this case, what happened? One oxygen is combined with two hydrogen. Okay, we already know that the valency of hydrogen is 1. What is the valency of hydrogen? Is 1. Okay, so 2 hydrogens. So oxygen is combined with 2 hydrogens. Okay, yes. So here, what is the valency of oxygen here? Yes, it is 2 because it's combined with 2 hydrogens. Okay, so we can decide that the valency of oxygen is 2 here because hydrogen can combine with only 1 atom. But here the oxygen combined with 2 oxygen, 2 separate hydrogen. Okay, so we can say that 2 hydrogens, two separate hydrogens are combined with 1 oxygen. So what about the valency of oxygen here? It is 2. Okay, because valency oxygen can combine with 2 hydrogen, 2 atoms. So the valency of oxygen here is 2. Okay, yes. So, since some of the elements do not combine with hydrogen, the valency of the element is also defined in terms of other elements like chlorine or oxygen. So this is because almost all the elements combine with chlorine and oxygen. Okay, since some of the elements, so all the elements are not making bond with the hydrogen, so we can decide the valency of other atoms when compared with the oxygen and chlorine. Okay, so next we will talk about the valency with respect to oxygen. Valency with respect to oxygen, chlorine. And before that, the valency of atom is given here, the table, the hydrogen chloride, the element attached with the chlorine, attached with the hydrogen is chlorine. Yes, before that, we will talk about see in the table 12.2, the molecule form is HCl. Valency with respect to hydrogen. Okay, here HCl, the element which is attached with the hydrogen is chlorine. Is it? Okay, and what about the valency of this chlorine? Okay, one chlorine is attached with one hydrogen, so the valency of chlorine is 1. Okay, next the water molecule H2O. Okay, so here the atom which is attached to the hydrogen is what? Oxygen. Okay, so how many, see here, in an oxygen atom, how many hydrogens are attached with the oxygen? There are 2. So what is the valency of oxygen here? We can decide the valency of oxygen, the other element. Okay, so here we are going to find out the valency of oxygen. Okay, here we take the valency of oxygen. Already we know the valency of hydrogen is 1. It is standard. Okay, so definitely, so oxygen, there are 2 hydrogen here. So the valency of oxygen must be 2. Yes. Next, ammonia, NH3. So here, which atom is combined with hydrogen? The nitrogen atom. Okay, so which is combined with the nitrogen? Sorry, hydrogen. Is this? Nitrogen atom is combined with the hydrogen here. Okay, so here 3 atoms are there. 3 separate hydrogens are there. Okay, so 1 N is combined with 2 hydrogen, 3 hydrogen. So what is the valency of hydrogen here? Okay, what is the valency of hydrogen here? It is 3. Okay, yes. Next, methane. We'll take another example, methane, that is CH4. Okay, so here the atom which is combined with hydrogen is carbon. Is it? Combined is carbon. And what about the valency of this carbon? Yes. So here there are 4 hydrogens. So here in this case CH4. There are 4 hydrogens. Okay, the valency of hydrogen is 1. So 4 hydrogens are combined with 1 carbon. So here this carbon is combined with 4 hydrogen. So what is the valency of carbon here? It is 4. Okay, the valency of carbon is 4. Okay, yes. So valency of carbon is 4. So we can determine the valency of other atom when it is combined with hydrogen. Okay, yes. So next, the valency with respect to chlorine. Next, the valency with respect to chlorine. Valency with respect to chlorine. Since valency of chlorine is 1, the number of chlorine atoms with which one atom of an element can combine is called as valency. In sodium chloride NaCl molecule, one chlorine atom combines with one sodium atom. So the valency of sodium is 1. But in magnesium chloride MgCl2, the valency of magnesium is 2 because it combines with 2 chlorine atoms. Okay, so here the chlorine atom can combine with only one atom. Since valency of chlorine is 1, okay, we already know the valency of hydrogen is 1. Of chlorine is 1. Valency of chlorine is 1. Valency of chlorine is 1. Okay, yes. Okay, we already seen that in the outermost shell, chlorine has only 1 electron. So it can share its 1 electron with other atoms. Okay, so valency of chlorine is 1. Okay, if in the formation of sodium chloride in NaCl, so here we already know the valency of chlorine is 1 here. So only 1 atom. So sodium it is attached with only 1 number of chlorine. So we can decide that sodium, the valency of sodium is 1. Valency of sodium is 1. Okay, and what about the Mg2O? That is the magnesium chloride. Okay, sorry, magnesium chloride. In the magnesium chloride, we already know chlorine has a valency of 1. So there are 2 chlorine atoms. Okay, this 2 chlorine atom is attached with 1 magnesium. Is it? So here we can say that the magnesium is attached with 2 chlorine. So the valency of magnesium is 2. Is it? So the valency of magnesium here it is 2. Because it combined with 2 chlorine atom. Okay, yes. Next, valency with respect to oxygen. Okay, next we are going to learn the valency with respect to oxygen. In another way, valency can be defined as double the number of oxygen atoms with which one atom of an element can combine, because valency of oxygen is 2. For example, in magnesium oxide, the valency of magnesium is 2. Okay, so we already we know that the valency of oxygen is 2. Okay, what is valency of oxygen? Is 2. Its electronic configuration is 18. Okay, so it contains, yes. So oxygen, the valency of oxygen is 2. Valency of oxygen is 2. Okay, how we can determine the valency of other atoms when it is attached with oxygen? Okay, so for example, here we are taking the magnesium oxide, MgO. Okay, so here the valency of both magnesium and oxygen is 2. Okay, we can decide the valency of magnesium is 2. How? Because the valency of oxygen is 2. Okay, 2 magnesium is combined with 2 oxygen. So here the valency of oxygen is 2 and the valency of magnesium is 2. So the valency of oxygen is 2, the valency of magnesium is 2. Okay. Okay, so when we can decide that the magnesium valency of magnesium is 2 because it is attached with 1 oxygen. Okay, so because its valency is 2. Yes. Valency with respect to oxygen. So far we have discussed the valency with respect to some atoms like hydrogen, oxygen and chlorine. Okay, so next we will continue with the variable valency. So atoms of same element combine with atoms of other element and form more than one product. Thus they are said to have different combining capacity. Okay, so the atoms contain different combining capacity. Okay, they produce different products. Okay, the variable valency. Okay, atoms of some elements combine with atoms of other elements and form more than one product. Okay, they are said to have the different combining capacity. These atoms have more than one valency. Okay, some atoms contains more than one valency. Sometimes it contains, for example, we will explain with the example. See, for example, these atoms have, so for example, copper combined with oxygen and forms two products, namely cuprous oxide and cupric oxide. See, copper combines with oxygen and forms cupric oxide and cuprous oxide. Okay, what is the formula for the cupric oxide? It is Cu2O. And what is the cuprous oxide? Cuprous oxide is Cu2O. Cuprous oxide and cupric oxide. Okay, so here we already know the valency of oxygen is 2. The valency of oxygen is 2. So here the valency of oxygen is 1. Copper is 1. Okay, see. So here 2, the valency of copper, the valency of oxygen is 2. Okay, that means 2 oxygen is attached with 1 copper. And here the valency of copper is 1. Okay, and what about here? The oxygen combined with 2 copper and the copper combines with 2 oxygen. Okay, so here the valency of copper here it is 1 in the cuprous oxide. Okay, in the cuprous oxide, the valency of copper is 1. The valency of copper is 1 in this cuprous oxide. And what about in the cupric oxide? In the cupric oxide, the valency of copper is 2. Okay? Yes. So the valency of copper is 1 in cupric oxide in CuO. Valency of copper is 2. See here, in Cu2O, the valency of copper is 1. Okay, and in CuO, the valency of copper is 2. Okay, for lower valency, for lower valency, the suffix OUS is added. So here the valency of copper is 1, so it has a lower valency. So the suffix OUS is used to represent this compound. Okay, and what about here? Here, the valence of copper is 2. So, the suffix IC is added. Cupric. Okay, the suffix IC is added to mention the higher valency of copper. Okay, yes. So, for higher valency, a suffix IC is attached at the end of the name of the compound. Okay. Sometimes the Roman numerals such as 1, 2 and 3, 4 or etc. indicated in the parenthesis followed by the name of the metal can also be used. So that is given in the table. See, the metals with variable valency, the examples are first one, the copper. The copper forms the Cu plus. Okay, so here it forms actually a cation, is it? Yes. So if you see the positive charge, we should write it as, we should consider that as cation. Okay, Cu plus. So here, what is the name of this copper? And the copper forms Cu plus ion, that is called the cuprous. Okay. So here in this case, the valency of copper is 1. Okay, the valency of copper is 1. So we are using the suffix OUS. This is cuprous. And here, next one, the cation Cu2 plus. Okay, so here the valency of copper is 2. So it is called as cupric. Okay, in the same manner, there are some other examples are given. Iron, which is formed Fe2 plus and Fe3 plus. Okay, so here in this case, we can write the cuprous. So otherwise, we can write it as copper in the bracket, in the parenthesis, the Roman letter 1. Okay, because that means the valence of the copper here it is 1. And what about the cupric? We can write it as copper 2 in the parenthesis. Okay, yes, the Roman letter 2. Okay, that indicates that the valency of carbon here it is 2. Okay, like that we have the iron Fe2 plus and Fe3 plus. So iron Fe2 plus which has a lower valency. Okay, Fe2 plus and Fe3 plus. So here it is called as ferrous and it is called as ferric. Ferrous and ferric. Okay? Yes. Otherwise, you can write it as iron 2. Is it? Iron 2. Here you write it as iron 3. Iron 2, okay, otherwise you can write it as iron 3. Okay? Yes. Next, mercury is given. Hg plus is called as mercurous or mercury 1. Hg2 plus is called as mercuric or mercury 2. And stannous, that is tin, is called as stannous or tin 2. Or stannic Sn4 plus is called as stannic or tin 4. Okay? So, in this manner, we can write the variable valency of certain atoms. Okay, so valency of atoms, the valency of all the atoms are not exhibiting the same valency. Some atoms contains a variable valency. Okay, sometimes the valency of copper, for example, sometimes the valency of copper is 1. Sometimes the valency of copper may be 2. Okay, yes. To make it stable, the valency of copper is varies. Okay? Yes. So in this case, In the cuprous oxide, for example, cuprous oxide, in the cuprous oxide, the valency of copper is 1. So, to denote the lower valency, the suffix OUS is added at the end of the name. And here, in the cupric oxide, the valency of copper is 2. The valency of copper is 2. So, it has a higher electron, it has a higher valency. So to denote the higher valency, the suffix IC is added at the end of the name. Okay, and also we can write the Roman letters in the parenthesis followed by the metal's name. Okay, so for example, here cuprous oxide. The cuprous oxide, here the metal is copper. And what about the valency? It is 1. Okay. And what about the copper? In the cupric oxide, the valency, the metal is a copper. And what about the valency of the copper? Here it is 2. And likewise, iron forms, sometimes the valency of iron is 2, sometimes it's 3. Okay. Yes. So if the valency of iron is 2, that is ferrous, we call as ferrous. If the valency of iron is 3, then it is called ferric. Otherwise, we can write as iron 2. Okay, iron 2 is the valency of iron, here it is 2. And here in this case, the valency of iron is 3. Okay, yes. So that means ferrous means, the ferrous means FeO. Okay, for example, the ferrous, we can write it as FeO. And what about ferric? It is Fe2O3. Okay, so here both have the valency of 2. But here in this case, the valency of oxygen is 2 and valency of iron is 3. Okay, so we can write it as ferric or iron 3 in the brackets. Okay, the Roman letter 3 in the bracket. That means this ferric, that means the valency of this iron, the valency of this atom is 3. Okay, yes. Next, we are going to continue with the ions. So what is mean by ions? See, already we have the idea of ions, is it? In an atom, the number of proton is equal to the number of electron, and so the atom is electrically neutral. But during chemical reactions, atom try to attain the stable electronic configuration, that means it try to attain the duplet or octet. So either by gaining or losing one or more electrons according to their valency. When an atom gains one electron, it has more number of electrons and thus it carries negative charge. And in the same time, when an atom loses an electron, it becomes positive charge. So these atoms which carry positive or negative charges are called ions. The number of electrons gained or lost by atoms shows as a subscript to the right to its symbol. When an atom loses an electron, positive sign shown in the superscript and negative sign is shown in if an electron gained by an atom. Okay, so we already know. So what are the ions? Okay, so here we already discussed with the sodium. We are going to take the sodium and chlorine. Again we will refresh it. Okay, so here in this case, sodium possesses positive charge and chlorine possesses minus charge. So what is the reason? Yes. Here the electronic configuration of sodium is 2, before losing their electron or gaining their electron, the electronic configuration of sodium is 2, 8 and 1. Here chlorine is 2, 8 and 7. Okay, yes. So to make it stable, okay, what the electrons are? All the atoms. So we already know in an atom the number of protons is equals to number of electrons. So in this sodium there are 11 protons and 11 electrons. And what about in the chlorine? 17 proton and 17 electron. Okay, but all the atoms are trying to attain their stable electronic configuration. That means they are trying to attain their tuplet or octet electronic configuration. Okay, that means in the outermost shell they are trying to possess their 8 electron configuration. Okay, 2 electron or 8 electron configuration. Okay, yes. So to make it stable, what the sodium is doing is losing its 1 electron. Okay, if sodium loses 1 electron, what about the proton and electron in their atom? Yes, 11 proton and 10 electron. Okay, so here the number of proton is 5 in this atom. So we will write it as Na plus. Okay, that means sodium loses 1 electron. Okay, sodium loses 1 electron. That means 1 positive charge. 1 proton is excess in this sodium atom. Okay, 11 proton and 10 electrons. So that's why only 1 proton is extra in this atom. And what about here? The chlorine. So if chlorine gains 1 electron, the electronic configuration of chlorine becomes 17 proton and 18 electron. So here you notice the number of electron is more. Okay, so here one number of electron is excess in this atom. So we can write it as chlorine minus. Okay, that means 1 electron is excess when compared to the number of proton. Okay, Cl minus. Okay, yes. So we can conclude that if an atom loses its electron, it will become positively charged ion. That means cation. Okay, positively charged ion. Okay, here in this case, if an electron, if an atom gain 1 electron, that will become negatively charged electrons. What is that? Negatively charged atom. Sorry, negatively charged atom. Okay, if an atom gains 1 electron, that will become negatively charged atom. That is called anion. Okay, so here it is called anion. Here in this case it is called anion. Yes. And what about, see, if the gaining and losing of electron is represented by the sign, the plus sign in the superscript. Okay, see here Na plus. The plus sign is, the plus sign is represented at the superscript of the sodium atom. Okay, yes. So here in this case, the sodium loses 1 electron. Here in this case, chlorine gains 1 electron. Okay? Yes. Sometimes 2 or more atoms of different elements collectively lose or gain electrons to acquire positive or negative charge. Thus, we can say an atom or group of atoms, when they either lose or gain electrons, get converted into ions or radicals. So we can conclude that if an atom gains or loses electron, it will become anions. Sorry, it will become ions. Okay, like cation or anion. If an atom loses electron, that is become cation. If an atom gains an electron, that becomes anion. Okay? Yes. So next, the types of ions, that means the cations and anions that we discussed. So ions are classified into 2 types. They are cations and anions, as we already seen. So cations, if an atom loses 1 or more electrons during a chemical reaction, it will have a more number of positive charge on it. So they are called cations or positive radicals. Sodium atom loses 1 electron to attain the stability and becomes cation. Sodium ion is represented as Na plus. Okay, so here in this case, in your book, the electronic configuration of sodium is given. Yes. Okay, sodium, 11 proton, 2 electron in the next shell, and the next shell they have 8 electrons. And in the next shell they have only 1 electron. Okay, after losing this electron, if after losing 1 electron, it becomes stable. Okay, yes, it contains the stable electronic configuration like 2, 8. Is it 11 proton and 10 electron? That is 2, 8. Okay, yes. So 2 electron. So in this case, 8 electrons. Okay, yes. And what about the chlorine? Chlorine forms a cation. Is it? Sorry, chlorine forms the anion. Okay, here in this case, chlorine gains an electron and forms the anion. In this case, what happens? So chlorine contains 17 proton in their nucleus and 17 electron in their outermost shell before it becomes stable. Okay, yes, 2 electrons. So here are 8 electrons. But the last shell has 7 electrons. The last shell has 7 electrons. 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6, 7. Okay, yes. So it has 7 electrons in the outermost shell. If this chlorine gains an electron, it becomes stable. Okay, 17 proton, but 18 electron in the outermost shell. So there also which has 8 electrons. Okay, yes. So in this way they are forming the anions, like ions. The cations, cation and anion. So what are the types of ions? Cation and anion. Okay, if an atom loses its electron, it becomes cation. If an atom gains its electron, it forms an anion. Okay, so all the atoms are trying to, why they are making the ions? Because they are trying to attain their stable electronic configuration like tubulet and octet. Okay, yes. Yes. So far we have learned about the Thomson's atomic model, Thomson's atom model, the variable valency, the types of valency with respect to their atoms like hydrogen, oxygen and chlorine, then the variable valency, next ions and the types of ions. Okay, the remaining we will see in the next class. Thank you.